Thank you.
All right, welcome everybody. My name is Scott Sauber, and today I'm going to be talking to you about test-driven development with Blazor. So I have already posted these slides up on my blog. It's just my first and last name, scottsauber.com, so you can check those out there. And if you want, you can follow me on Twitter and really any social media at Scott Sauber. So today, just to kind of level set with everybody in the room of like who I had in mind when I created this talk. Because if this isn't you, maybe this isn't the talk for you, and hopefully we kind of come in with the same assumptions, basically. So really, I'm targeting anybody who's familiar with Blazor. That said, if you're doing like React or Angular or Vue or whatever the case is, really the concepts that I'm going to cover apply across the board. So even if you're not familiar with Blazor, like really you can apply these TDD front-end concepts in any front-end technology that's out there. And also just people who are interested in learning TDD. So I'm going to cover what TDD is. So you don't have to come in and know TDD or be a TDD expert or anything like that, because I'm kind of going to walk through what it is, as well as if you think like, oh, I know TDD, it's red, green, refactor. I've actually got another step in there that isn't quite the same as red, green, refactor, but we'll talk about that here in a second. So we're going to talk about what is TDD, like why should you care about it exactly. I'm also going to talk about the tools you can use specifically with Blazor, but if you have other tools like you're using React or Angular, just drop a comment in the chat and I can share some tools that you can use to TDD those technologies as well. But then also a lot of people will say like, oh, well, what do I test on the front end? So we'll kind of talk about all of that. Including should you test your CSS? So we'll talk about that a little bit later as well. And you'll also see me do a live coding demo. I'm actually in a hotel right now because I'm at the Dev Intersection Orlando conference. I just gave a couple talks yesterday. So I'm not at my normal keyboard setup, so we'll see how this goes. But really what I hope for you to get out of this today is just learn some best practices for writing front-end tests. And really, I kind of hate the term best practices because usually like best practices are just like my opinions with the like types of applications and the context that I'm in and things like that. Because a lot of times best practices have context with them, but I'll try and leave you with some like best practices that I think most people can take advantage of for writing front-end tests. As well as I've been in the React community since 2016 or so and done React in there. And I feel like there's a lot of learnings from the React community that the .NET community still hasn't quite fully adopted. So I'll share some of those learnings from the React community as well. And then also we will learn how to TDD with Blazor. So who am I? I'm the Director of Engineering at Lean Techniques. We're a software consulting company based in the US. And we work with kind of Fortune 500 companies down to startups and everything in between. So kind of what we do is teach people more modern practices such as TDD, CI/CD, those kinds of things, moving to the cloud. And really our goal is to like help you build the things, but also teach you how to build the things so then long-term we can go away. So that's kind of what we do. Microsoft MVP, Dometrain author, Redgate Community Ambassador, and I help run the Iowa.NET user group. And I've used Blazor, Angular, React since about 2015. So I've kind of bounced between those different technologies. Okay, so first question that I get is why do we write tests? Well, biggest thing is we want confidence that our application still works after we make a change, because I'm guessing many people out there have written a bug before. And if you haven't, you must be the best programmer I know, because everybody's written a bug before, right? And how bugs come about is we make a change to this part of the application over here, and it has some unintended side effect. Maybe it's in like a completely different part of the application. Maybe it's in the same part, whatever the case is. So we want confidence that, hey, when we make these changes to our applications, that everything still works how we expected. This also minimizes manual verifications. So I'm guessing a lot of you or many of you out there have been on teams that has manual QA. I'm not really going to get into that necessarily today, but I will say like if all you have is manual QA, what I see time and time again is as an application adds more and more features, the amount of things that a manual QA has to manually verify goes up and up and up. Or maybe you're using a product owner, business analyst, whatever, to do that manual verification. And so as you add more features to an application, basically the amount of testing required scales like in lockstep with the amount of features that you're adding. So by introducing automation to those things, we can reduce the need for all that manual verification, and just scales nicer as an application grows. You can also document your behavior through your tests, because your test should tell you exactly how your application should behave, which is really nice, especially if you come into an application completely brand new, never seen it before. It's really nice to read through the test to see what the application should do. So that's like automated testing, but let's next talk about what TDD, test-driven development, is. And really it came from this book, I would say, is kind of the catalyst that I believe was released in 2003. So it's been out for 2 decades now, and it was written by Kent Beck. And I mean, it's honestly still a good read. Like if you pick it up, all the examples are in Java, but really the concepts still apply. And I would say really the fundamentals don't really change. Even in like an AI driven world, like our fundamentals as software engineers don't change. Like we still need to validate that what we did didn't break things and that everything works as we expected. So Kent kind of laid out what the TDD process is. So a lot of people will think to themselves, okay, TDD, like what's the first step in TDD? And a lot of people who are familiar with TDD will say red. And while that's accurate, I would say there's another step even before that. That's the think step. So it's like, and we'll kind of get into this here in a little bit here in a minute, but I would say TDD is kind of like a methodology for writing code, and the tests are just a nice byproduct. So you write the test before you write the production code, which can be a little like, for people who haven't done it before, that can be a little like, how do I possibly test something, write a test for something that doesn't exist? And I'll show you a live example, like I'll live code it so you can see kind of how this works. It's really not as bad as you might think, or as hard as you might think. So again, how do you do this? Again, the first step is not red, in my opinion. It's to think and think about like, okay, what am I going to write a test for next? Like what, in the case of front ends, I think it's super easy, because you just need to get in the mindset of what does my user care about? Like I've got a user story in front of me that says, hey, as an administrator, I expect these buttons to exist because I'm an administrator, whatever the case is. Just like reading through the acceptance criteria of a story is usually a great starting point for, hey, what test should I write? So the first step is think about like, hey, what test do I want to write? And then you want to write a test that describes the behavior that you want to see. And we'll get into behavior a little bit later. And then you want to run the test and watch it fail for the right reason. What I mean by that, and we'll do again another live demo of this, is some people, like I'm pretty sure Uncle Bob will say that, and I think maybe Martin Fowler too, I can't remember, it will say like compilation failure is a valid red state, meaning the app doesn't even compile, therefore the test fails, right? I don't really believe that. Like I want the application to compile and throw, if I'm testing a method, throw a not implemented exception, or if I'm doing an integration test, like it throws a 404 saying this API doesn't exist, whatever the case is. Or in our case with Blazor, we'll say like, hey, we'll look for some markup, and that markup's not going to exist. I want to make sure that it fails for that reason, because it's super easy to write a test that you think is testing the right thing, but actually isn't. And when you rely on compilation failures, you don't know that maybe your test is always green because of the way you set it up, like you asserted on the wrong things, whatever the case is. And we'll kind of get into that here in a second. And then you need to write the code to make the test pass. And you can always choose to just write the simplest code that will possibly work, hard code certain things. And then, the next test will force you to usually make it more robust and things like that. So if you don't know like exactly what step is next, you can always hard code things. And I'll show an example of that here in a second. And then the next step after TDD, or after you get the code to pass and the test to pass, is to refactor, because now that we ran the test, prove that the functionality does not exist in our application, and then we watched it pass, meaning we added code to our application, and now we've proven that, hey, this functionality used to not be here, but now it is. Now we're safe to safely refactor things. So maybe I want to like consolidate methods or refactor methods or whatever the case is, move things around. Now is a safe time to do that. However, only do things on one side of the equation or the other. So don't refactor your test side and your production code at the same time. refactor your production code, rerun the test, make sure it still passes, then refactor your tests if need be, run the code, make sure it still passes. So don't change both at the same time, because now you've basically lost that proof of like, I saw it fail, I saw it pass, because you can make a change that makes something always pass, or things like that. Like a lot of things can go wrong. So that's a key takeaway with TDD, is when you're doing the refactor step, only change one side of the equation, either the test or the production code, not both sides at once. And then you kind of repeat this cycle. So after you write your first test, then and get it to pass and refactor, then you move on to the next test and think about like, hey, what's the next piece of functionality I should think about? Like maybe I should look at the acceptance criteria again and see like, hey, what exactly does this story require? And then you kind of repeat this process over and over and over again. So what that kind of visually looks like is the first step is to think, and then you move on to the red state of writing the test, watch it fail, make it pass with the green state, and then refactor, and kind of continuously do that loop until you're good, and then you move on to the think state. So a nice part of this is I kind of have a tendency to kind of go down rabbit holes and things like that, and like be like, oh, I'm trying to add this feature, but I see I need to refactor this thing over here. And then I go down that rabbit hole. And really, I should have like done that refactoring in like a separate pull request or a separate story or whatever altogether. And the nice part about TDD is it focuses you on just making that test pass. So it's really helpful for me. And honestly, that's one of the bigger benefits out of it for me, is the focus, not necessarily the test that you get at the end. That's just kind of a nice side effect. And I really like this quote from Eric Evans. He said, if you haven't seen a test fail, you don't know if it works. Because again, I'm sure many of you have seen this as well, where a test basically was set up in a way that it can't ever possibly fail, because maybe it was mocking something that was mocking things incorrectly, or maybe it was asserting on the wrong thing. Whatever the case is, there's definitely situations where a test can never fail. So if you've never seen it fail, you never do that red step, you don't actually know if it works. So that's kind of the problem with test after, where like you might write a bunch of production code and then kind of backfill tests, is you don't actually know that those tests are testing what you think it's testing. Whereas the red-green step kind of proves that you targeted the right behavior in your production code. Okay, so why test-driven development? I already kind of alluded to some of this, is allows you to work in small steps. And I would argue in like an AI-driven world, working in small steps is even more important than, when we were coding in hard mode without AI, because especially if you're using like agents or things like that, you can definitely go off the rails, and AI can do way too much. So I think TDD kind of forces you to work in those small steps. It also allows you to minimize waste, because again, you're not doing like those crazy changes or like going down rabbit holes. You're just like focusing on getting that test to pass. And then that also minimizes your work in progress, because again, all you're doing is trying to get that test to pass. You're not worried about the 14 other things you have yet to do. You'll get to those a little bit later. Like I said, the biggest thing for me is the focus side of things. I also find I spend a lot less time in the debugger, which is kind of a interesting side effect you don't think about, because if you think about like all the time you're spending in the debugger, if you're not doing TDD or you're not writing tests, what if you could take all that time, maybe like 30 minutes a day, whatever it is, and put that towards writing tests that then have continuous value and continuously add value to your application by verifying the behavior of your application. So I just find I spend a lot less time in the debugger. And the reason is behind that is I'm just so focused on like a small piece of functionality that when, let's say I implement the production code and rerun it and it still fails, usually immediately I know exactly what it is, because I'm usually just working on a small chunk of code at a time. So it just leads to much less time in the debugger. So I'm not coding up like, I don't know, like your traditional like repository services, controllers, all that fun stuff. And then like something doesn't work and you don't know where it is because you just coded up, 8 different methods along the way. And so you got to traverse through the debugger to figure out where the issue is. So that's a nice side benefit of TDD. As well as you think through your failure states of, hey, how can this possibly go wrong? And with that, then you can, I find that you like make more resilient code, because you're thinking through like, okay, what's the next thing I should write? How can this next piece of behavior fail and like write a test for that and think through that. But then at the end of the day, it also gives you confidence that like, hey, if all the tests pass, that gives you confidence that, hey, my application actually works. As well as another kind of thing that people don't think about is it also gives you design feedback. Because if you think about, like, let's say you have a 1,000-line method or a 5-line method, which one do you think is harder to maintain? I'm going to say probably the 1,000-line method, right? And usually writing a test for a 1,000-line method is much harder than writing a test for like a 5-line method. And so if you find, hey, this is really hard to write a test for, it could be a pause point of like, hey, maybe this method is doing too much, or this component's doing too much, or whatever the case is. And maybe the design of my code is wrong. So I also like that design feedback that TDD and tests in general give me. So that's also another side benefit. But again, oh yeah, the regression tests that you get at the end of the day are nice too. So there's like tons of benefits here that aren't even like the regression tests that you get at the end of the day, to make sure like, hey, I made this change. This feature I wrote 3 months ago still works. So that's, again, a nice side benefit. Okay. So I talked about what TDD is. So what is not TDD? Because sometimes people say like, oh, I do TDD, and they don't exactly know what that means. So TDD is not a synonym for writing tests. Again, it's kind of a way in which you approach software where you start with the test first. So it doesn't mean you're writing tests. Like, you can write tests, but write tests after you write the production code, and that's not TDD. TDD is also not writing multiple tests up front before writing any production code. So it's not like, hey, I'm going to write these 20 tests up front before I write any production code. That's not really TDD, because you're going like a bunch of red over and over again, and not doing the red, green refactor steps. As well as, TDD does not mean no bugs ever. Just in my experience, it leads to less bugs. And there's a lot of metrics research out there, such as from Dora. I'm not really going to get into that today, but if you go to dora.dev, that's a DevOps research assessment. They do like analysis of high performing teams. And one of the things that they call out that makes a high performing team, from their research of like tens of thousands of teams, is writing automated tests. And that's how people move faster, more confidently, all that kind of stuff. TDD is also not really used for adding tests to existing production code, because if you think about it, if the production code already exists, like you got some legacy code or some untested code out there, it just means that you can't really TDD it, because you can't go like red, green, because the code already exists, right? So usually when you're backporting tests to existing code or legacy code, you can't really TDD it. You're more just adding code after the fact. You can do some tricks, like for instance, you can target some behavior, write the tests, and then like comment out the code or remove the code from the production code and make sure it fails, then put it back in and make sure it passes. So you can do some of those kinds of tricks, but by nature, because the code already exists, you can't really truly TDD it. I also think there's a lot of like TDDs, I'll say TDD zealots out there, who will say things on Twitter or Blue Sky or LinkedIn about like, hey, if you're not doing TDD, your code isn't good. And I just don't believe that that's the case. And I think it's kind of like gatekeepy and things like that. Like, people can write good code without TDD. Like, it's totally valid. And I just think TDD helps you write good code and things like that. But people are like just zealots about it. Like, and if you're one of those people, please stop. Like, you're just turning people off if you say like, oh, you're not writing good code unless you're doing TDD, because like, I want you to think about like, if you're doing that, or some people are doing that, like, you almost never change somebody's mind by behaving that way. So instead, trying to introduce them to TDD, teach them those things, like if you're passionate about that. So I'm not personally a zealot about it. And I see a lot of people turned off on TDD because certain people are like zealots about TDD. So just want to share that as well. Okay, so that first like 15 minutes, 18 minutes or so was about TDD in general. So now let's apply TDD to Blazor, because that's kind of why we're here, right? So I'm going to introduce a few different tools that you'll need in your tool belt, and you can swap these out, specifically the first two with other tools, but these are the ones I'm going to show. So the first one is XUnit. So if you're not familiar with XUnit, it's a test framework. It's actually used by Microsoft to test .NET itself. So like the ASP.NET Core team and the .NET team use XUnit to test .NET itself. Like you can go check out their GitHub, and that's what they're using. So I've got a test here, and this is testing the classic counter component. So this is a test that's saying, hey, it should increment the count when clicking the increment button. As part of this test, the only part that's really XUnit is this fact attribute up here that's saying, hey, that's basically marking this as a test. So that's the only part of where XUnit really comes in. Where shouldly comes in, this is a library that I use. That's an assertion library. It's got roughly 80 million downloads on NuGet, and it usually leads to cleaner assertions, meaning at some point in the test, you have to assert and say like, hey, this is the behavior I expect my application to have. And so where that comes in is at the bottom here. So in this case, after you click the increment button, I'm expecting the text content should be current count 1, right? So that should be is part of where shouldly comes in, where it's an extension method off of object, and it allows you to do different things based on or have more natural reading language versus if you're using traditional XUnit assertions, those are fine too. I'm not going to die on this hill that you should be using shouldly, but like the XUnit assertions sometimes don't read as clean as that because it'll be like assert dot equal and then you pass in the 2 parameters or something like that. So I personally use shouldly, but again, I'm not going to die on that hill. Okay, and lastly, bUnit. What bUnit is, it's a helper library for testing Blazor, and it helps you render out components and then basically query the DOM that gets rendered out from those components, the HTML that gets rendered out from the components, and allows you to inspect things, interact with things, click on buttons, assert on things, all of that kind of stuff. bUnit also allows you to inject in like fake dependencies. So if you are making an HTTP call, you can swap that out, not make a real HTTP call. You can mock that out and just do like a fake HTTP response, as well as you can do things like fake out the navigation manager to change the fake out the navigation manager to change out the routing and things like that. So and test the routing. So that's kind of some things that bUnit adds for you out of the box. So where bUnit kind of comes in is this middle part where kind of the base thing that you need to know is the test context. So the test context is thing that allows you to actually render out the component, and then you can kind of find different things on the component, interact with it. Like in this case, I'm clicking on the increment button there, kind of on that 4th line there of the block, and also like find different pieces of the component, and then we can assert on it later. So that's kind of where the bUnit part comes in. So now for a big part of this talk, and probably one of the bigger questions people have is like, okay, cool, I see TDD, but like what should I write, or I like kind of understand what TDD is, but what should I write tests for? And the biggest piece of advice I can give you is behavior. And what I mean by that is like what your user cares about. And if you frame all of your tests, whether you're doing Blazor or any other front-end technology, if you frame all of your tests on like, hey, what's the user's behavior here, then I think that helps guide what tests you should write. So for instance, I don't test that CSS classes exist because what is the point of CSS? The point of CSS is to make sure that something looks nice, right? And looks pretty. You can't prove that something looks pretty or looks nice by testing that a CSS class exists. Like if I say, hey, I've got these 5 CSS classes on this particular HTML element, that doesn't really tell me that the component looks pretty. So I personally don't test CSS classes. Now there's a slight nuance there where if I'm toggling a CSS class based on somebody like checking a box and maybe it like pops something open or whatever the case is, or turns something red, that's something that I do test for. Like maybe you have a table of elements and you turn some of them red and some of them green to indicate, good or bad records or things like that. Like I would write a test to make sure that the CSS class for like green and red are there, because that's behavior that my users are expecting, is I'm toggling things based on some certain conditions. But otherwise, if it's just like static CSS classes, I don't test that those exist, because again, testing that those exist on the element doesn't really tell me anything that the CSS actually like works well together and looks good at the end of the day. Like you're just going to have to go look at it manually. So again, focus on the behavior of your application. And so kind of a litmus test, and this is probably a key takeaway. So if you're kind of tuning out, tune back in for at least a hot second, is if like a key takeaway is if I can delete production code that breaks your application, but no test breaks, to me, that's a problem, right? So that means that I'm not covering that particular behavior in one of my tests. And what I find is when you don't have good test coverage around these things to say like, hey, I'm confident that the majority of the behavior of my application is covered, then I find people start tiptoeing around the application. And that's where you can't move as fast. Now, there is a slight nuance to that of like, because every rule has reasons to break the rule. Like, for instance, if the like cost of maintaining that test is so large because you're interacting with like tons of third-party things that you don't control or whatever the case is, which you can still mock those out. And so it's not really a good example. But if for some reason there's a test that's really hard to maintain, really expensive to maintain, and the cost of breaking is less than the cost of maintaining it, then I might not write a test for it. But generally speaking, I always think like that's usually a refactor opportunity where I could test whatever behavior that I'm doing. But so there are reasons to break the rule, but in general, I follow this rule of if I can delete production code that breaks your app and no test breaks, that's a problem. It means we're missing a test somewhere. So, but there's kind of the flip side of that too. Like if my tests break, but my application isn't broken, that's also a problem. Like maybe I run a test 100 times and 1 out of 100 times the test breaks and 99 times out of 100 it passes. That usually means that you have some sort of flaky test where there might be some like race condition thing. And especially with front end code, that can happen where like maybe you're making an API call that you're mocking out, or you're doing some other calculations and you're like checking the HTML before that calculation or whatever it is finishes running. So you kind of need to, there's different techniques to kind of wait on things and wait for elements to be visible or wait for elements to have certain values, those kinds of things. But in general, if there's a flaky test, don't just rerun and like something fails and you rerun it and it passes. Don't just accept it and be like, whatever, it's fine, because I guarantee you that flaky test is going to come back later. So like inspect it, figure out what's going on. You can even use AI tools to help you debug where this flakiness is, things like that. But there's also not just flaky tests, but like you also might be leaking implementation details. So let's say you do refactoring, and I'll do a simple one a little bit here in a little bit of, doing a refactoring that doesn't change the behavior of the application. It just changes the implementation of it. If your test breaks because of that, usually that means you're leaking implementation details into your tests. So in general, if you kind of focus on this user behavior aspect of things, then usually you have more resilient tests to refactorings because you're not leaking implementation details. So if I look at this test here, there is a bit of a problem with this assertion. So I accidentally clicked next, so you might have seen it real quick. But I want you to think about what could be the problem with that assertion that we have there. So it's basically the same test we had before. We're incrementing the count when we click the button. And now we're asserting that the component instance has a property called current count that should be 1. And current count is really just an implementation detail because this is like the property on the underlying Blazor component class. And like our users don't care about that, right? So some people might be like, okay, let's instead use this markup matches thing that's built into bUnit where I can make sure that the markup matches this, where I've got this p tag with a role of status and then the current count is 1. And I would say this is a step in the right direction, but now we're starting to bring in some more HTML that's more of an implementation detail. So let's say I add a CSS class here that, adds a padding or whatever the case is, or maybe I switch this p tag to a span or a div or whatever the case is. Like that's kind of an implementation detail. Like our users don't care what tags we're using and things like that. So we're kind of leaking some of that into our test. So in general, I'll talk about this a little bit later, but I try to avoid markup matches. So instead, what I would do is I would grab that element just like we did and check the text content and say that that text content should be current count 1. And so by finding it by the role, which is like if you go file new project with Blazor, you'll kind of end up with the markup where the role is status. Like that's kind of the role that the element is playing. So I'm abstracted away from, hey, is this a p tag, a div, a span, whatever it is. It doesn't really matter because really all my users care about is that the current count is 1. So if we kind of look at those 3 side by side, I would do the bottom one, again, to just be abstracted away from as much implementation details as possible. And I really like this quote from Kent C. Dodds. So he's pretty big in the React community, and he created the most popular like bUnit equivalent in the React space called React Testing Library. And Kent C. Dodds has this quote that I think this is also a guiding principle for you as you're writing tests, because these principles don't change no matter what technologies you're using, is the more your tests resemble the way your software is used, the more confidence they can give you. So part of what Kent's saying there is if you're focused on how your your tests are more focused on how your users use your application, then they're abstracted away from those implementation details, like I mentioned. So in general, this is like one of the key guiding principles of writing front-end tests, in my opinion. Like if I could give people one quote, this would be it, or one sentence, this would probably be it. Okay, so what should I not test? So I mentioned earlier, don't test CSS because, again, CSS's intention is to make your app look good, and you can't test to make sure your app look good. So app actually looks good. You just have to look at it. Maybe in the future, AI can do some analysis to make sure it looks good, but for now, it's not really a mainstream thing. Try not to test implementation details, as I mentioned. And I also avoid using markup matches because, again, markup matches takes some block of HTML and asserts that that block of HTML is there, which can be problematic because, again, you're leaking all those implementation details. So like adding an attribute will break that test, even though your application is not broken from a user's perspective. Now, I will say if you're creating like a component library, maybe that makes sense to use markup matches because some people might be dependent on the way the markup is. But in general, if you're writing a Blazor application and not a component library, then I avoid using markup matches. Again, there's just too many implementation details like CSS classes, what nodes you're using, all that kind of stuff. I also don't like using .instance because in bUnit you can use grab like the underlying Blazor class. And again, when I see people use this, usually it leads to them leaking implementation details. So don't use .instance for applications either. For component libraries, maybe like your component toggles something and it flips like a property from false to true or true to false. Maybe in that case, it makes sense to test the instance, but in general, for applications, you should be focused on the user behavior. Because again, you're leaking too much implementation details like calling properties, methods, and things like that. Because sometimes people will like go like the component.instance and like invoke the method that's underlying behind those things. And almost always that method is wired up to some like element like a button or whatever the case is. And I would rather interact with a button because that's really what the user cares about, not they don't care about what the method is. So again, more guiding principles along that stuff. I also avoid snapshot tests like verify. So what verify does is it basically takes like your basic component and renders out into JSON and kind of saves it into your project. And then it verifies that the markup matches what was in that JSON file. And so in general, I avoid snapshot tests for all the reasons I already mentioned, because snapshots don't capture what your desired behavior is. They just capture all this HTML at the end of the day. So again, it's got the same problems that I already mentioned where you've got all these implementation details. So what I see people doing sometimes is they'll change some HTML stuff and then their snapshot test fails because they've changed the HTML, and then they just like blindly accept the updated version and don't actually analyze what happened there. As well as you literally by definition cannot TDD with verify because verify relies on the final output. So if you're using verify, I'm just not a huge fan of it for all those reasons. And you can't really, again, you can't verify something until like the production code is there. And you can't really make it green unless you update your snapshot. However, I do use Verify or other snapshotting tools when I'm like refactoring completely how a component should work, but the HTML output should be the same. So I might create an initial test that's using Verify or some other snapshotting technology that is like, hey, when this component's in this certain state, it should have this HTML at the end of the day. And so like I'll create that test, add the snapshot, and then do my refactor, and then make sure that the test still passes and the HTML is still the same. Because if that's my intent, is like I'm just reworking the logic of this, but the output should still be the same, I will keep have that test verify that. But then afterwards, I delete the test because it basically proved that I didn't break something. But going forward, I don't want to maintain that test. So then I delete that test. So that's just kind of what I do. Okay. So let's go ahead and do some live coding here. So I'm just going to go ahead and run the application here. This is more or less just a vanilla Blazor application with some slight modifications. But what we're first going to test is our trusty friend, the counter component. So when I click things or click this button, then it increments the count, right? So that's our trusty friend, the counter component. So I'm actually going to delete all of this code and not have the counter component here anymore. And instead, I'm going to, so usually, I guess, if you haven't done tests before, usually you have a separate test project. And this is kind of where you install XUnit, shouldly, bUnit, all that kind of stuff. And then when I lay out my code, usually I just kind of mimic the folder structure of whatever it is that I'm testing. So in my case, the counter is under pages. So I'm going to put it under pages here. But you can see I don't have really anything in here at all. So I'm going to go ahead and use a live snippet from Writer and say to scaffold out my test. And usually my kind of format is it should do something when a condition happens. I don't really care if that's how you name things. I don't care if you use underscores. I more care that you're consistent, but whatever it is, just pick something and go with it. So I'm going to say should have an initial count of 0 when the component loads. So we'll start there. So with bUnit, the first thing you need is a test context. So I'm going to go ahead and create a new test context here. And you can do things like this, and that's how you get access to the component. So if I do that here, I can go context.render component and get access to my counter component. But what a lot of people do is instead of this, they will just inherit from test context. Inherit from test context, and then basically you've got access to render component at that point. So that's what a lot of people do. And so that's what I will do here. So the next thing I'm going to do is I'm going to say, hey, I want to find the current count, and say I'm going to spell count with a capital C and say component.find and say current count. So I'm going to have some sort of element with an ID of current count. And then I'm going to say the current count dot text content. Yes, basically that. I will say the current count text content should be current count 0, right? So I'm going to go ahead and run this test. I am using keyboard shortcut to do this. I highly recommend you look at what your keyboard shortcuts are because it can make TDD even faster. You can kind of like right click and see, like for me, I'm on Windows and under this key map. And so mine's Control UR. So you can always look at that as well. Okay, so now you notice I get a failure, and I'm a little zoomed in here. So sorry if that's, there's a lot going on here, but the error I get is no elements were found that match the selector current count, which makes sense, right? Because I didn't actually create an element that has that ID. So this is where I'm verifying that my red state is in the state that I expect. So I'm going to go ahead and do the simplest thing that could possibly work. And I'm going to create an element with the ID of current count. And I'm just going to hard code the value in here of current count 0 and then rerun the test. So maybe I don't always do it like so super simple like this. Sometimes I will write the code that I know I need to write, but generally speaking, you can just write the simplest code because what will come out is the next test you write. So let's go ahead and just for speed, I will duplicate this here real quick and say it should increment the count when the increment button is clicked, right? So I'm going to want to make that 1 instead of 0. And I'm going to also need to grab the increment button. So I'm going to go ahead and find the button element here, and I'm going to click it. So really nothing super crazy there. And then I should make sure that basically just asserting that that change from 0 to 1. So this is where kind of tests are kind of working together, because this one I'm not clicking on a button and it's 0, and then I am doing something over here different, and this one is 1. So you notice that one failed. It says no elements found that button, which makes sense. So I'm going to go ahead and add an increment button. I'm not going to really worry about CSS here or anything like that. I'll go ahead and add that increment button, rerun the test, and it will still fail. But just want to show you that we are getting different errors here. So it's saying, hey, I want an on-click handler here. So I'm going to go ahead and create an on-click handler. I'm going to go ahead and create a local method. I'm going to move you actually down here. And now I've got this increment method. And what I really want to do is I want to increase the current count, but I don't have a current count. So I'm going to go ahead and create a field for that. And I'll just leave it at that because it's going to default to 0. So if I now rerun it, now it won't yell at me that I don't have that click handler. Now it's saying, hey, the current count should have been 1, but it's 0 because I still have it hard-coded. So let's go ahead and fix that too. Now when I rerun all of those tests, they should all pass. So that initial increment button test pass, I'll now do a different test to make sure that different keyboard shortcut to make sure they all pass, and they do. So you can kind of keep iterating on this. I'm not going to keep going in the interest of time, but you can kind of imagine how this continues to work. So you can still keep iterating on these things and do TDD with front end code and kind of, again, drive that behavior that's in your applications. Okay, so I'm going to take a slight TDD detour because I try and talk about this wherever I can because it's one of my favorite principles. And there's a guy named Russian playwright named Anton Chekhov who lived in the 1800s. And Anton said, basically, if there's like a rifle hanging on the wall in the first act, then it should be fired in a later act. Otherwise, it shouldn't be hanging on the wall. And what he means by that is everything should have relevance to the story and everything should add to the story. So how does this relate to testing? Well, I want you to look at this test here, and this is not a Blazor test. It's just like pure C# code. And I want you to think about like, what is the thing that is not relevant to the story with this test? So I'll give you like 5-10 seconds to look at this and see what's not relevant to the story here. So the answer is basically everything that is not last name. Like the only thing that's really relevant there is last name. Like first name, address, birthday, it's just muddying up things. And it's not immediately obvious when you first glance at it that like, hey, this test just cares about last name. But I see this all the time where people put way too much in their range step of their tests. Like they might be mocking a bunch of stuff that they don't need to, whatever the case is, or they could like globalize that mock because it's always returning the same thing. But I really want tests that are focused on the behavior that they're trying to test. So like a simple refactor would be like to create like some sort of valid customer method or like a factory or whatever you want to do. You could also use random data like bogus and things like that to create some of the stuff and then just tweak the change that I want to make. But I usually go next step, and in XUnit, I'll rip that out to the constructor, and that does not share state between the different tests because each test runs with like a brand new fresh class because that's just how XUnit works. But I'll like have some field that's customer that's like set to a valid state, and then I'll just tweak it as needed in the other tests. But then I'll also go next level here too, and also extract out the customer validator. So rather than newing it up in each test, I'll also rip that out into the constructor because that way not each test has to new up that validator. And if there's ever like dependencies that need to be added or things like that, that's kind of where like I can do that in one place in the constructor, not in every single test. So we kind of look at these two side by side. You can see, and this is like a super trivial example. Like I've seen arrange steps that are like 30 lines of setup that could be reduced down to like 1 or 2 in each test. And so it's a lot more clear that, hey, this test just cares about last name. It doesn't care about all this other stuff. Okay, so that's Chekhov's gun. So hopefully you remember that principle and also can apply it to your tests. It's not exactly just useful for TDD, but it's useful for any automated tests that you might write. Okay, next I'm going to talk about bUnit web.query. So this is an extension to bUnit. It's another package that allows you to query the DOM that are even less implementation specific than what I showed earlier. So this is more in the React testing library style. So if you're familiar with React testing library or Angular testing library, this kind of draws on those parallels. And these queries promote accessibility. So I'll show an example of that here in a second, but it promotes people who are using screen readers and things like that. But also, like even if you're not using a screen reader, you can still mess up accessibility that affects everybody who is not using screen reader as well. Because if you've ever like been to a website and you're like looking at a checkbox or radio button and you click on the text and it doesn't actually check the box or check the radio button, that means they didn't wire up the input in the label and the input of the checkbox or radio button together. And so that also hurts screen readers, but it also hurts people who are not on screen readers as well and who are trying to check that particular thing. So like bUnit web query, make sure that you do those things so your applications don't have that problem. This is something that I worked on with the two other maintainers of bUnit. And we're still going to come out with more in the next 6 months. Honestly, we've just been kind of busy with personal stuff, so we haven't really added things to it, but we work together on what I'm about to show right now. So let's look at that here real quick. So if I come over here to and run the application again, there is a loan application tab here. So if I close out of that and click over here, so it's a pretty simple application or simple page, and hopefully you're just you kind of get the point. Is like if I submit without filling out anything, I get some error messages, and if I fill out first name, I'll say like, hey, thank you for submitting first name, right? So, or I probably should have said first last, not first name, but anyway, you get the point. That's kind of all this application does. But you look at this form and you're like, oh, okay, it's perfectly fine, right? And so if we look at the code for this, so if I go look at the loan application tests, so this is also another little tip is if you're trying to navigate to a certain file, you can use like the humps, the capital letters. So I did like loan application test. So I just did LAT. So again, just a tip for you as you're navigating around Writer. And you can see here what I'm testing is that, hey, it should show a validation error when first name is null. So basically I'm trying to find first name, and then I go ahead and click the submit button and make sure that the message shows up. And actually this name of this test is wrong. It should show success message when first name is not null. I'll just say when form is valid and submitted. I accidentally named that test wrong. So glad we could pair program on that. But one kind of interesting thing here is it's finding these inputs based on the IDs. So if we go look at the loan application.razor, what I'm using for this is the input text, and I'm using just a placeholder of first name. Well, placeholders are really, like I see this happen over and over and over again, where people use placeholders for labels, and placeholders are not accessibility friendly. And really placeholders are intended to be like showing an example. Like for instance, if you've got like a date field, it shows you like the date format it expects, right? But a lot of people use placeholders for first name or for inputs, which is technically not valid. So if we swap out this find for a component.findByLabel text, which comes from bUnit.web.query, and we rerun this test, you can see previously all these passed, but now if I rerun this test fails in saying, hey, I couldn't find a label with a text of first name. So it's catching this accessibility issue within my test, which is pretty sweet, and will probably make certain people in your company happy if you do this. So a few different ways to solve this. I could do an ARIA label of first name. So if I rerun that, that's one way of making that pass. And you can see now it passes, but the more proper way to do this is to just not use placeholders at all and instead use like a label that's like first name, and then you wire that up by saying, hey, the ID, the for of attribute of the label should match the ID of the input. So if I go ahead and rerun that test here, that should pass as well. So there's a lot of different ways you can wire up the inputs to the labels, but just want to share that because a lot of people who are using bUnit today don't know that get by label tech or find by label text method exists. So I just want to call that out, and we're going to add some other ones here in the future as well for like finding buttons and things like that based on the role that they have. So more to come probably in the next 6-ish months once we prioritize it. Okay. So that was a quick tour around, automated testing in general, as well as TDD, how you apply TDD to Blazor. So kind of, I get a lot of people say like, how can I get started with TDD? Like I don't use TDD today. How can I get started? And I would say probably one of the simplest ways to get started is when you have some sort of bug report come in that says like, hey, I expected this behavior, but this is the behavior that I got instead. You can write a test to prove that that bug exists, and like write a test to make sure that basically the test will fail because it doesn't do the behavior you want. And then you can fix it and then make sure it's green and then basically proving that you fix it. So like that's a super simple way to get started with TDD, and honestly like a great starting point before you start doing it for new features and things like that. So again, write failing test, prove that bugs exist and make it pass. But I also hear this statement from people sometimes who are like, well, I don't have time to write tests, or I don't have time to do TDD. And there is an upfront cost to it, but I usually ask them like, well, why don't you have time to do this? And sometimes they're like, my boss won't let me. And I'm kind of like, well, why does your boss kind of get a say in how you write software? Like they should more just care about the outcomes that you create and less about like how it's implemented, right? So like imagine if you went to your surgeon and you're like, hey, doc, I need the surgery. And your surgeon was like, okay, that surgery is going to take about 4 hours or so. And if you're like, doc, I can't do it in 4 hours. I can only do 15 minutes. What can you do? What can you do about the surgery in 15 minutes? And would you really want to go to that surgeon's like, oh yeah, well, normally take 4 hours, but I just won't wash my tools. Instead of 20 stitches, I'll just use 3, like all that kind of stuff to get you down to 15 minutes. So sometimes it's like, we would never expect a surgeon to make that trade-off, right? Like whatever they think says goes basically, right? So like, I don't really understand why we like as professionals, like we know what's best because, we're in this industry. And so we should make kind of the tools or the choices of, hey, here's how we can best solve this problem that you have. And as long as we solve the problem correctly, you shouldn't really need to ask like permission or any of those kinds of things because you're just getting the person the outcome that they wanted. But like another thing that I want to leave people with too is like, you don't get better at TDD by not doing TDD, right? And so like, if you want to get better at this stuff, it's just like anything. Like you didn't come out of the womb knowing how to program, right? Like you went to classes, watched blogs, watched videos like this, all of that kind of stuff. And you put in a lot of effort to get good at programming and be proficient that way. And it's the same thing with TDD, just like any other skill is in order to get good at something, you actually need to do it. And sometimes I hear like also like, oh, well, we don't have time because, we're too busy fixing bugs. And it's like, well, why do you have so many bugs? It's like, well, we're busy fixing bugs because we don't have any automated tests. And because we don't have any automated tests, that leads to more bugs. And then you kind of end up in this endless cycle. So eventually you need to break that cycle and start implementing automated tests because the data is out there. They've done the studies. Automated tests does make you move faster long term. There is a little bit of an upfront cost, but it allows you to move faster and more confidently and more reliably in the future. So with that, we got like 7 minutes or so for questions, but some takeaways hopefully you get out of this. Hopefully you take away like, why you should do TDD, as well as how to test Blazor and what to test in Blazor. But again, if you're using another front-end technology, you can pretty much apply these principles anywhere, and hopefully it helps you get started TDDing Blazor. Got some resources here. So this TDD by Example book by Kevin Beck, highly recommend reading it. It's not that terrible or like long of a read, so it's still totally relevant. There's this Write Test blog post by Kenzie Dodds that I really like too, specifically for front-end testing. I have posted like the demo code to this talks repo that I've got. And I've also got the slide deck, which I posted on my blog. It's just scottsauber.com. And I intentionally leave a lot of my slide decks detailed, so that way you can use them as a reference and they're like a standalone, hopefully value add. Because I always hate when I download slides and it's like just a picture and I'm like, I don't remember what that person said about that picture. So hopefully you can share this with your team if they're not here, or reference it later if you want to look at it later. So yeah, that's what I've got. So I'll take any questions or do some discussion now. And I know not everybody also likes asking questions in front of everybody, so I threw my email on there as well as my LinkedIn. So if you want to add me on LinkedIn or follow that bit.ly, that'll take me to my LinkedIn too. If you want to have any questions or like, how do I test this particular scenario? Happy to answer anything people have.
Thank you, Scott. That's very generous of you. But we do have some questions for you. But first of all, let me say that I really appreciated the quotes that you provided, particularly the one, what does it say? If you haven't seen a test fail, you don't know if it works. I want it on a t-shirt, really. Brilliant.
Yep.
Yeah. Sorry, Sasha.
Yep, Matt. No, go ahead, please.
Yeah, no, I thoroughly enjoyed that session. Yeah, TDDer of old, so I enjoy this kind of thing, and I do like that. And one thing I don't normally kind of flag this too much; it's a little bit on the nose, but I did like the little demo you did of Ryder doing create from usage. Quite a lot of people don't necessarily know this, and they don't see this in the context of TDD, but it's really good. You can write a thing like you're doing current count, I think it was. You were using the current count because I want to use an increment. I want a counter, so I'll use current count. It doesn't exist. Alt enter, create variable, create field, and so on. Those features in Ryder are really, really useful for test-driven development because the test really is driving the thing you're building.
Yep, absolutely. And especially when you're just like, writing methods and classes and things like that. Like I will literally like new up a class that doesn't exist or a record that doesn't exist and just alt enter, have it create the class, so use keyboard shortcuts to like move it around to a different project and all that kind of stuff. So
the tooling can help you be the tooling can help you be really quick at doing this. It can feel like it could be cumbersome, but the tooling can really help. Anyway, I'll stop fanboying about Ryder now.
No worries.
Now, I guess onto the questions. I found one in the chat that I found particularly interesting and very specific. Sharp-eye productions using plain strings to find things makes stuff easy to break with renaming. Is there any way to make this safer?
Sorry, can you repeat the first part of that? Strings for like the CSS, CSS
using
selectors?
Using plain strings to find things makes stuff easy to break with renaming. Is there any way to make it safer?
Yep. This is an it depends, but I'll try and talk about certain scenarios that hopefully this person's thinking about. So like, for instance, when I showed the example of like bUnit web query that was finding by label text, like in general, your labels don't really change super often. Like it's pretty much first space name, and that's just what it is. So that's a big reason behind bUnit web query is to make your tests more resilient that way. As far as like for instance, when I was showing the current count and doing like current count colon, and let's say I change that colon to a dash, yes, that would break your test in that case. But you're also like, I find in practice, you don't actually hit that scenario super often because like, let's say somebody asks you to change that colon to a dash, right? They like more than likely somebody asked you to do that. And so that is like a behavior change. Like they didn't like that colon. They want to switch it to a dash. And so like, you're really changing behavior. Somebody thinks that that's important, even though that's like a super contrived example. So as far as like those two things go, that's kind of what I would say. As far as CSS selectors go, Yeah, in general, if you can use the find by label text for grabbing inputs and checkboxes and radio buttons and things like that, that'll be more resilient. But otherwise, you can just use like IDs of elements, and so you're not trying to grab like, hey, I'm trying to grab this p tag or whatever the case is. I'm just trying to grab this ID, and I'm really abstracted away from what kind of element that is. So that's generally speaking what I would do, and kind of what I've experienced. So hopefully that answers the question. But yeah, if they have a follow-up, feel free to let me know.
Matt, did you want to throw out the next question?
Yeah, there's another question from the chat there. I think I'm going to paraphrase it a little bit, actually. The idea when you talk about Chekhov's gun, Chekhov's test, and only using what is actually required, sometimes that can be really difficult if you've got, say, data that you're wanting to create, which this is kind of a throwback to Martin's talk a little bit. If you've got something with non-nullable types, for example, how do you kind of deal with only setting the stuff that's required for the test, but at the same time, your business objects require more data? There's a sort of tension there, really, isn't there?
Yep. So that's where I would kind of do similar to what I had in my examples of, like, I might have a factory that creates one that's like, it could just be random data. It doesn't matter. It's just like in a valid state, basically. And then I tweak that to whatever I want. Or maybe I don't even tweak it because maybe I'm just keeping the valid state and I'm like submitting a form. Like, then I wouldn't tweak that, but I would probably abstract that away to like another method or like the constructor way, and kind of have that in a valid state. So that way downstream tests don't really have to care about that. Because if you're setting like a required keyword or something like that on a property, obviously you're going to have to set those values, but you don't have to do it in the block of the test. You can move that out to a method or the constructor or whatever the case is. So again, the tests you're looking at are clean, and you kind of move that irrelevancy, I'll say, into another spot. So you're not looking at it all the time.
Okay, I like the idea of that. So that the required bit then, for example, would stay in the test, but everything else you could kind of push out. So at least the test is a bit focused.
Yep.
Something like that.
Yep.
Cool.
Yeah, and it's kind of hard to. It's a lot easier to talk about this stuff when there's like a code example sitting in front of you and like, here's exactly what I would do. But hopefully those kind of principles help people.
That's true. That sounds good to me.
Yep.
What's next? Sasha, have you got a question?
Yeah, it really gave me a chuckle, that analogy with the surgeon when trying to convince your stubborn team leader or boss about the necessity of TDD. Yeah, it got me thinking, do you think that TDD is still a practical, feasible, viable approach for teams under time constraints, under time pressure?
Yep. So I would say, like, again, it depends. Like, if the world is on fire and you got to fix something and to TDD it would cause you to take you 8 hours or something like that, then yeah, be pragmatic and don't have your whole, like, if you're Amazon.com and Amazon's down, it's probably bad, and you're probably losing a lot of money, and just get that thing up as soon as you can. But ideally you would kind of swoop back around and then fix it, I would say, properly. So just be pragmatic. I'm not, again, a zealot of like, you have to TDD all the time. Like, I tend to more often than not, but that there's certainly situations where you shouldn't, or like it doesn't make sense to. However, I would say you can always fall into a trap of, oh, well, I just don't have time this time. Oh, I don't have time this time. I don't have time this time. And then you never make time for it. So like, I think it is a slippery slope once you say, like, obviously if production's down, that's like a whole different ball game. But you can always make excuses as to why you're not doing it. And again, you don't get better at doing it by not doing it. You just got to dive in. And again, if anybody has any questions about like, how would I TDD this scenario, like, happy to, if it's not obvious, I like talking about this stuff. So happy to answer any questions, and you don't have to send me Venmo or anything. I'll just help you. So.
Excellent. You also mentioned working, these days everything's changing. It's the obligatory AI question. You mentioned AI. Can you use TDD as an approach with AI and agents? Because it feels, like I was saying with the create from usage, it feels like more like a mechanical process.
Yeah. So I would say yes. There's lots of different ways you can interact with AI with TDD. I mean, you could be the one who writes the test, but AI is the one who implements it, makes it pass. Or you could do the flip side. You could have AI write the tests and then you implement it. Or you can actually instruct certain AI tools to follow TDD and make sure that, hey, run the tests first, make sure they fail, and then run the test after you add some implementation code and make sure they pass. What I will say though is like reemphasizing like AI is not great at this moment about doing like large batches of work. Like AI is kind of like a junior developer of sorts right now, at least, or at least in my experience. And if you tell a junior developer, hey, go build this whole application from scratch and create thousands of files and stuff like that, it's going to go off the rails. But if you focus it, then it generally does a great job if you're using the right tooling and models and things like that. So I actually think TDD is even more important in the AI world because you're allowing it to focus on, hey, you're just solving this small problem, or you're just doing this small thing, or just trying to get certain tests to pass. So it kind of focuses you because I think that's where I see people fall down with AI tools is they told it to do a big thing. It generated, hundreds or even more lines of code, and then they don't understand it, and it almost takes them like, but something's broken and they're not sure why, and things like that. But again, if you kind of focus on, I'm just implementing a small feature, I find AI tools are super helpful.
Yeah, good advice. I think small steps helps with those kinds of things. As you say, keeps it more focused.
Yep, for sure. But I mean, you saw the autocomplete that was in Writer too, so that's some AI tooling where it's predicting what I want next, and in general in my situation is pretty good. So
yep, that's true.
I also liked your point about if something is hard to test, perhaps the design might be off. I honestly don't remember if it was during this presentation or the other one you gave for one of Writer's webinars. But anyway, my question is, do you think there is something like specific about, in your experience, about Blazor components that makes them harder to test, perhaps?
I think it's more just like a education problem more than anything. Like I don't think like a Blazor component is more or less harder to test than like a method. But certainly if your Blazor component is doing like 40 different things and it's 400 lines long, like that's going to be hard to test, just like a 400 line method is generally hard to test. So I think if you can kind of keep components focused, as well as like sometimes we have like child components in Blazor firing off API calls, and we're firing off like 10 API calls in a full page, and maybe that's not what we should be doing. So I think I don't necessarily think that Blazor components are harder to test. It's just more of an education thing. And I think if you keep that user focus of like, hey, what does the user expect to happen? I actually think it's easier to write tests that are not implementation detail specific than backend code. Like if you're mocking, like, if you're, this gets into a lot of different things, but if you're mocking every service and things like that, like anytime you mock, you're basically tying yourself to implementation details. So I find with Blazor components, that's actually easier not to tie yourself to implementation details because usually you're not mocking a ton of stuff. So, but yeah, that gets into mocking, which is like its own hour-long session probably by itself. But and people have lots of opinions about it. But so yeah, that's just my perspective. But I know that's not everybody's perspective, and I've also been writing tests for front-end code for close to a decade now, so I totally get that it probably comes more natural to me than some other people.
And a follow-up, you mentioned that writing a bunch of tests, you mentioned not writing a bunch of tests because that's red. So is TDD does it really require a fast feedback cycle?
Yeah, absolutely. Like if your tests run in like, let's just say 5 seconds, 10 seconds, something like that, like that's way too long. Like ideally your tests are running in, I mean, as fast as possible, but ideally like milliseconds. And generally speaking, I mean, you saw it on the bUnit tests, they're running pretty fast. And that was with me. Technically this laptop's a little underpowered and it's like 4 years old. And I'm sharing my screen and all that fun stuff. So there's a lot going on. I think it was still running pretty fast. So I would say if your test is running in like, I'm going to just say a second or more, like a bUnit test is running a second or more, that would give me a lot of pause. But even like hundreds of milliseconds. I'm like, why is it taking that long? It's
Mm.
because generally speaking, a lot of those are running in under 100 milliseconds, if not like under 10 milliseconds. So when the actually execution of it starts, there's obviously some boot up time to like build the app and all of that kind of stuff. But once that all kind of process happens, then the rest of it should kind of fly through.
Yeah, I was wondering if Blazor has an overhead for, in this area.
Yeah, I mean, certainly it does over just, if you're just testing like a HTML page by itself, because it's got to actually do things and stuff like that, but like a static HTML page. But I mean, I could go look at what these tests passed in, and I'm pretty zoomed in. Looks like 15 milliseconds. So on average, 10 milliseconds, things like that. So I mean, it's running pretty fast.
That'll work.
Yep.
Yeah, good. Yeah, cool. You also mentioned with mocking there as well. I noticed one of the things you didn't really say, I don't think you mentioned, maybe even for the whole thing, was unit testing. You were talking more about testing and test-driven development. So what would be your unit here?
Yeah.
Also, I guess the other question is, with Blazor, how do you deal with sort of isolating? What are about the seams and isolating things?
Yep.
By opening the mocking question.
This is opening up a can of worms, because I'd say like our people's definition of unit testing is so all over the board. I'll use my definition. So I think, well, I'll talk about an integration test, because some people are like, oh, an integration test is it's hitting a database or it's hitting a network, all that kind of stuff. And all that stuff is true. But I think an integration test can also happen all in memory. Like if you have two methods calling each other and they're all in memory, I still think that's an integration test, because you're integrating two pieces of code together, even if it's not hitting network or file system or any of that kind of stuff. And I think it's the same for Blazor tests. So I think a lot of Blazor tests are more integration style tests, even though it isn't actually like bUnit's not actually, I guess I didn't mention this, bUnit isn't actually spinning up a browser or anything under the hood. Like you didn't see a browser spin up when I ran the test. That's all happening in memory. And so even though it's happening all in memory, I still kind of consider them integration tests, because I'm testing multiple components together, even some like the validation one, the loan application one that I demoed at the end, that was testing like some input text components that come out of the box with Blazor. So I consider those more integration style tests, even though, yeah, they're not hitting network. So I'd say in general, front-end tests to me are more valuable for integration style tests and not like mocking out separate components. But again, it's kind of it depends, because I have mocked out like third-party components at times if they're doing a lot of stuff. It just kind of depends again. But I think if you're trying to isolate some behavior, you can always test it at like the lowest component level, or rip out some behavior to a component, just like you would rip out some logic in C# to a method. Like it's literally the same concept. So if you're trying to isolate something and just test that by itself and not all this other stuff around it, you can always do that.
Yeah, great. We've got one last question, I think, from the chat, actually. Nearly missed this one. Could you tell us about testing pages that require authentication or authorization?
Yep. So bUnit has built-in ways. Can I share it in the chat? They have built-in ways where you can, like if you will bUnit authorization, you can mock out basically the authorization authentication. So you can say like, hey, I'm coming to this page or this component as an unauthenticated user, or a user with these permissions or these claims or these roles or whatever you're using. So you can basically mock all that out and still test that functionality, because maybe you pop up like you're not allowed to view this page, or you just pop up a generic 404, whatever the case is, when you're not authenticated, but you do show it when you are authenticated. So you can test all that stuff out via mocking, and that's kind of built into bUnit.
Okay.
And
that's nice,
now
if you tools.
Yep. Yeah, for sure. And you can always go up a level. So bUnit's kind of at that unit integrations level of tests. It's not doing like an end-to-end test where it's spinning up a browser and things like that. So you can always move up to like Playwright or Cypress or any of those kinds of things. Selenium to test end-to-end style tests. So if you want to not mock out the authentication side of things and actually log in and do that kind of stuff, You can certainly do that with like Playwright, for instance, is kind of my go-to recommendation. But a downside of that is we're not going to run in milliseconds anymore. We're spinning up a browser. It's going to run in seconds. So usually you have less of those. So I kind of reserve those end-to-end style tests for more of the like critical paths of my functionality. So like Amazon.com, for instance, the most important thing on Amazon.com is you can search for a product, add it to a cart, place an order. Like I would absolutely have an end-to-end test around that. I would not probably have end-to-end tests, or if I did, not many, around like the my profile side of Amazon.com, because if that doesn't work, like it's probably not the end of the world. But not being able to place an order feels like it would be the end of the world.
It's pretty important, I think, for Amazon. It's a bit of a big deal.
Pretty important.
Yeah. Okay. Well, thank you very much for your session today, Scott. That was really interesting, and I think a lot of food for thought there. And being able to work in TDD would be a great way for a lot of people, I think.
Yeah, definitely. Yeah, thanks for having me. Appreciate it. And yeah, it was a lot of fun.
Great. Thank you very much. And we'll see you later.
Yep. See ya.